Hi, good evening. Welcome to another YouTube talk from Shropshire Wildlife Trust. Really pleased to be able an opportunity to use this kind of technology just to talk about the stuff we love to do and the stuff we love to explore and see, and spend a lot of time here working hard to create projects to look after. So this evening we're going to have a little look at the small stuff, the little bits and pieces that make up a river ecosystem. Last week we looked at aquatic ecology, but this week what are those beasts and creatures that make up that wondrous habitat? How's it all sort of come together? So my name's Pete, I'm the River Projects Manager from Shropshire Wildlife Trust. We have a team of 6 of us working away across the county on various different projects. But all those projects need to kind of mean something, and this evening, I say, just going to have a little bit of a review, a little bit of an intro to some of those species and plants and creatures that kind of make up the river universe. And just to set this kind of in context a little bit, we, as a county wildlife trust, work in Shropshire. Shropshire has 3,846 miles of watercourse, of that sort of ditch, pond, canal, stream, brook. This incredible arterial network flows and shifts and moves, driven by gravity. It tops up, driven by rain. And these sort of fundamental mechanisms create this crazy, as I say, sort of arterial network, this web of water. And obviously in between the actual water courses, we have wetlands and damp patches, little hollows in the north, and the meres and mosses landscape, those ice age reminders or remainders from that period. And in the south we have peat bogs and wet flushes and mires. So water's quite a dominant feature of the landscape, and it creates special conditions for wildlife to live in. Some to thrive, some to kind of live on the edge of their existence, just about there, just about hanging on. Running through the centre of our county we have the River Severn, 220 miles from source to sea, rises in the Pinlimmon Mountains in mid-Wales. By the time it gets to the borders of Shropshire up near Llandrynio, Melverley, it's quite broad and powerful and muscular. Running through the centre of town, this lovely picture here of somewhere I potter through quite frequently. It's over the English Bridge. It's a big, powerful natural phenomena. But within it, and you can see the ripples and the bows and the skating runs, are fish, aquatic invertebrates, floating and paddling along on the surface are a range of birds, and then flying either in their adult forms or they've wandered off the land across the water, a whole range of river flies of one sort or another. So I say, for the next sort of part of this session, we're going to have a little look at some of those animal and plant groups and just delve a little bit deeper under the surface and try and understand how the rivers in Shropshire kind of work and who lives by them and in them and survives by adapting to their watery nature. Firstly, we have these microorganisms. These are diatoms. They're unicellular, they're tiny, they're very dependent on the nutrient profile within a watercourse, within water chemistry, whether there's phosphates, nitrates, whether there's ammonia, the temperature, the pH, and these small organisms are very, very tiny. It can only be seen under a microscope. Will tell us a bit of a story about the water quality within lakes or pools or in moving water. And interestingly, they don't depend on light, they just consume organic matter. They move according to the flow of currents. And the different sorts, I mean, this photograph is quite nice. It represents the example of these kind of grapefruit slices and pimply golf balls or tetrahedral shapes, rods or lozenges. There are all sorts of different forms. And they kind of give away the nutrient levels in different water bodies. Particularly, let's take the meres in the north of the county. They will support particularly a particular sort of community of diatoms that contains one range of individuals. A mere quite close by that's got a different nutrient profile will support a different range of diatoms. And certainly monitoring agencies like the Environment Agency will use diatoms to understand whether the nutrient levels are of a healthy pitch, whether they're kind of okay, or whether you've got an absolute flush of a certain type of diatom that's indicative of an imbalance or an over-enrichment, or what a eutrophication. It's that nutrient enrichment where you just got far too much of that stuff. Maybe fertilizer or slurry or organic matter, might be grass, might be just cut grass from a domestic garden, causes an imbalance. And the diatoms will reflect that. Studying them requires a microscope, as I say, and it's certainly there's at least one, maybe two, maybe three specialists within our county that particularly like to get down with a slide, prepare a slide, pop it under a microscope and spend some time studying and understanding this microscopic world. Pardon me. Algae are fundamentally simple, plain, unicellular. Some of them can move. They can flip that flagellum around and move through the water. Some of them form long chains, and those chain forming algae will form blanket weed or mats on watercourses or on ponds or lakes. And again, something for the microscopy guys to get involved in is studying algae and understanding how they work. For somebody like myself who's a non-specialist, I tend to use them as an indicator maybe that the water's got a bit warm, maybe there's an imbalance in terms of the nutrient. Lots of new ponds, particularly if they've been filled with tap water. Tap water is not particularly good to fill a new pond. It's better to fill it slowly and patiently with rainwater. But a pond filled with tap water will tend in its first couple of seasons to end up with a coating of a blanket weed. And again, that's indicative of a nutrient imbalance. There's not sufficient plant life or a range of plant life to help balance those nutrient cycling in a way to resist the temptations of algae. In a pond, overnight, a lot of algae will break down and will reduce the oxygen levels. So there is a healthy basis for understanding that their presence doesn't always say the right thing about the health of a pond. And certainly in moving river systems, I was down on the Clun a couple of years ago. It was late summer. Slow was very, very slow. The flow was very, very slow. And in the slack backwaters, there are blanket algae had formed because the water levels in terms of temperature had risen and the oxygen had started to decline and nutrient pockets had built up. So algae, big field, big specialist field, but I think this evening we're just looking at these starting points, and certainly I'm hoping that at least one person out there is going to go, yeah, I think that's really cool, like algae, want to find out more. So for myself, it's kind of, okay, I think I understand what this group is about, and they're telling me a little bit of the story of this river or pond or ditch system. Slightly more complex is the blue-green algae. These are bacteria. They have a chlorophyllite content, so they can produce oxygen via photosynthesis. But some of the cyanobacteria are actually poisonous. And certainly when we're looking at the Meres or Horsehay Pool or some of the Telford lakes in that late summer, you'll see this blue-green, and it is quite a shiny metallic colour, will form in pockets and corners, particularly those just out of the wind or out of that drift, and they're indicative of the presence of blue-green algae. Certainly for dog walkers, it's just to keep your pets out of the water because it will upset human systems if it's ingested. But again, at a microscopic level, extremely interesting. They will form chains or groups, and they're important in terms of the conversion of atmospheric nitrogen, that's the nitrogen that's carried in the air, into an organic form. So they're part of the nutrient cycling. And I think without the algae, the nutrient cycling systems between the atmosphere and terrestrial and waterborne habitats will be disrupted and won't work effectively. So it is tempting to in a pond to maybe reach for a kind of a chemical solution and say, well, actually this is unattractive. I don't want my pond to look like this. But we have to be careful about the interventions we make because some of these algae are incredibly important in terms of the development, the longitudinal development of a pond's healthy balancing system. And in the early example of a freshly dug pond, that blanket algae is part of the early phases of development of a balanced and busy and diverse community in the pond. And its premature removal may mean you have a consequence. Now my pond, I dug it a couple of years ago, allowed it to fill full of rain, and it does have some algae, and I've been watching whether it's a dominant, and it isn't particularly dominant. It grows quite slowly. It seems to support because it provides cover a whole range of other invertebrates. So I'm tempted just to give it a little bit longer, just wait. The Glyceria, the sweet grass, is a bit more dominant, and that's starting to provide a bit too much cover across the pond as it floats out across the surface. So we're looking at a balance and trying to understand quite what we're looking at. So that's the blue-green algae and the blanket algae. A bit more complex, a bit more diverse, possibly easier to identify, but I'm not entirely sure. I've had a go myself. I've trekked the mountains up in the Barewinds just across the way from me in Wales with plastic sample bags in my pockets, a huge great mosses and liverwort book, and had a go. And I can see generally there's a difference. Getting down to specific species is really quite challenging. Those tiny little bracts and fronds and the leaf arrangements and the pods that release the spores to reproduce, the slight variations in colour, slightly browner, or is this redder, is this greener, is this light green, dark green? So quite challenging, but already you start to get a sense this is a massively diverse bryophyte, organism, and it's a study that's worthy of our time, and certainly there are people who've made it their kind of life's work, and at least one of the authors of my very heavy book is based in Shropshire, which is cool. They're also very fond of water. If they dry out, they'll desiccate. Sphagnum mosses are found in a whole range of particularly acidic type habitats where the water pH is quite low. And they form mats. They hold on to water, so they will attract other species who could shelter in there that need protection from drying out. And their diversity means there are specialised mosses. And some of them, like the one in that guy's hand, that's actually my hand, that's one of the water mosses. That's a riverine moss. It's quite large, and that was found in the River Perry up in sort of North Shropshire, attaching itself quite firmly to a rock, very fluid and flexible form to that particular moss, very long, quite large bracts, so its structures are bigger than a lot of mosses, which are really quite tiny, and you need a hand lens to see. So again, that was quite accessible. I was quite pleased because I worked hard on that one. I think I got about as close as I could to identifying it, which was nice. Liverworts are part of this sort of what we essentially something we could call non-flowering group of plants. Liverworts have a form that means that they can hold tight in waterfalls, in quite lively water environments, commonly seen on walls by bridges or in rocks under waterfalls. That's their kind of natural habitat. But because we like to build near water and in rivers, we tend to get them covered in liverworts eventually. Supergroup, again, quite complicated. So as long as you can divide them out and work out, well, that's actually not a moss, then I think that's a first faltering step towards much more secure ground. So as we move up the kind of animal kingdoms, we get into the plants. Now, this isn't a particularly good slide. And the slide was intended to show the zones. And I think with plants, it's important to understand where you found the plant. Is it in open water? Is it rooted on the bottom of the lake? Does it float? Is half of the plant actually sticking up above the water? Is the plant just in the wet ground on the edge? When the pond goes up or down, or when the river levels rise, it gets inundated from time to time? Or is it slightly further away? Is it a woody plant, sort of like a tree or a shrub? Is it one of the grasses? Is it a flowering plant and it emerges and it holds its flowers above the water? Does it disperse its flowers like the chirophytes underneath the water or just below it? So by using a zonal approach, by understanding different things would have and tolerate different types of living experiences or rooms, we will immediately start to decrease the difficulty of identifying aquatic plants. The other advantage we have with the aquatic plant world is there's less of them. As a specialised group, there's considerably less than in a wildflower meadow, for instance, which can quite easily, a particularly rich and gorgeous one, can quite easily outstrip the total number of plants in the nearby river or canal. One of my favourite little spots, I was there last night, is the Montgomery Canal up between Queen's Head and Rednor, and part of that's the triple SI, part of that is the reason because of the rare plants that are found there. I've never managed to identify any of the rare plants, but it has allowed me to start to get comfortable with the different sorts of plants, and it was a really good starting point for a bit of a journey in terms of understanding where these plants grow and how they behave and their different characteristics. So plants, take the zonal approach. If it's out in the middle of the lake, it can only be a certain range of plants. If it's on the edge, if it's marginal and it's emerging, think, oh, okay, I better look in that section of the book. And a lot of books will help you by approaching this or giving you, as this slide does, a little starter list for those different areas. So at the edges, we obviously have our trees, and we've got sort of willows and alders, ash and oak, more sort of drier tolerant species, will also grow near rivers. They provide shade. Their root systems consolidate the bank and provide shelter or hollows and small caves for other animals and creatures to hide in. They're one of the phenomena from riverside trees is they will actually drop insects and other invertebrates into the water. So you tend to get fish will actually sort of look for that shade because they know it's also a source of the occasional meal as it drops from the boughs above. Orchids, again, one of my little spots on the Mont's Canal, got some wet ground, so the pH is going to be sort of mucked about with, and it has some beautiful common spotted orchids in the season back in June. Water ravens, again, likes damp soil, quite a spectacular plant, and again, it will favour those sort of damp conditions. And one of the things to ponder about is that rivers, even canals, which seem to be fixed, fluctuate. Their water levels go up and down, and the range of water conditions, that kind of gradient between the dry and the wet, will change. And a riverbank or a lake or a pool tends to have what they call a drawdown zone. So that's the space between the kind of upper tide mark and the lower one. And in that drawdown zone, you might get, for instance, toad rush. Quite a nice little rush, very tiny, and it really likes the drawdown zone. It doesn't like to be in it. It can be inundated every now and then, and other times it needs to be drier, and it just quite happily coexisting in that zone between the wet, always wet, and the always dry. So here's some examples of emergent plants. In the centre is one of my favourites, the greater tussock sedge. It tends, because of its kind of Muppet-like armatures in this kind of fluffy head-like thing, it creates loads of spaces inside for other things, including water voles where they're found. We have amphibious bistorte that does quite literally that. It does either grow on the dry or it floats, and those beautiful pink heads will stick up above it. I think it's Randley Pool in Telford Town Park. It's got a lovely population of amphibious bistor in flower in the late season. Arrowhead, exactly what it says. The leaves are shaped like a large arrow. Again, an interesting plant, but that's an emergent plant. Yellow flag iris, very distinctive, large seed heads later in the year once those yellow petals are falling away. Is that correct? No. I still got this slide here. It's been here for years. I've got to correct it. At the bottom of this slide, it says bulrush. That is not correct. That is not a bulrush. That's another photograph of a reed mace. So reed mace, or the Americans call it cattails, it's got the fluffy cigar-like head that breaks up into fluff. Great for lighting fires but the bulrush, the scirpus, is not like that picture at all. So I will correct that, and next time I'm out, you'll see a different slide in that picture. Water plantains, again, quite a large group, the plantains, but you'll find a lot of the plants that are on terrestrial dry ground, those plant groups, have a water version. So forget-me-not, you've got the small-leaved, whatever, etc., and you have a water forget-me-not. Slightly different petal shape, flower head slightly different shape, the leaves are slightly different shape, but it's all part of the forget-me-not family. Except this particular version is by the water. And that's another, so you've got your zoning, and then you have these terrestrial versions, and you end up with aquatic versions, which again is really helpful to increase plant knowledge and sort of botanical identification. So in the shallows, we have water lilies, because these are rooting on the bottom, so the water can't be too deep. Some of the pond sedges will kind of shift out, and their root systems are in water. I mentioned that the sweetgrass, I've got the glyceria in my pond, so it tends to root in the softer muds, not too far away. It can't tolerate complete loss of oxygen, but they submerge and then they emerge. As the water gets deeper, you get these adaptations, and one of the really nice ones is the water crowfoot family. It's about half a dozen of those, and the photograph there illustrates the leaf on the surface. Below the surface, the leaves are a completely different shape. They tend to turn into sort of needles. They're very fluid, whereas the leaves on the top of the surface are broad. They're capturing more sunlight. They tend to be a bit stiffer, whereas the leaves below the surface are shaped to cope with flow, to shift and to move with the flow. Other things, we have Canadian pondweed, quite difficult to identify, but once you have a small frond of it, you can have a little look, and it has whorls of leaflets. By counting the number of leaflets on each whorl, we start to understand whether this has got 2 or 3 or 4, whatever. Hornworts do quite literally under a hand lens. When you look at those whorls, have tiny little horns on them. It's not quite a nice giveaway. And the horned pondweed is similar, but as you can see, quite a different structure, growth structure. Water soldier, it's an invasive. It's a bit of a nuisance again on some of our canal and river systems. And this picture was taken during the summer when the water soldier rises to the surface. And then during the winter, the whole plant descends and sits on the bottom. So it's quite a distinctive life cycle there. They've got very sharp edges and they're quite difficult to remove. And they tend to end up with shoals or sort of troops or battalions of water soldier, which is difficult to remove and outcompete native species. Unfortunately, within any of our plant and animal groups, we have invasive plants. These essentially are non-natives. They've been introduced to this country because they're decorative, or they've been introduced into this country because they've been brought in accidentally. And occasionally they've been introduced sort of mischievously, as a sort of uninformed or misinformed notion that this will be a benefit. Some of the sort of global examples, like the cane toad in Australia, they were brought in to manage a problem and then almost immediately became a problem themselves. So let's just explore sort of Japanese knotweed. It's a very dominant plant. If it grows, it forms a thick stand. It excludes all other native species. It's massively difficult to treat. Unfortunately, it requires chemical applications by injection into the stems, probably in the late summer. So with this, you have a very good reason to bring chemical treatments into the environment in order to manage this pest. It's economically damaging as well as ecologically, but a bad news story all round because it is mainly transmitted by vegetative. Tiny little pieces of Japanese knotweed are moved around and they take root and grow. And they do tend to travel up and down water courses. Himalayan balsam, the explosive steeds. Again, it does that same trick of excluding other species. And the New Zealand pygmy weed, that's a massively expanded or magnified picture, but will dominate a pond within a few seasons and is very, very difficult to control. So that was the plant world. Now we're going to spend a bit of time to explore the smaller, or what we call sort of macroinvertebrates. So we can see them with our own eyes. We might need a hand lens or a microscope to understand their finer features, but we can certainly see most of them with a hand lens. Flukes cause a range of illnesses because they're parasites. So some of them attach to the outside, so ectoplasm, and some are actually found inside an animal. They will predate on their host, and they tend to be a symptom of poor water quality, and they tend to reflect sort of overcrowding. So the carrying capacity of a pond or a riverbed has been exceeded. There's an imbalance in the food chain, in that food web, and you tend to get a rise in things like fluke. Sheep are prone to fluke infection, and so are we. Again, that's a peril of dirty water, and we need to maintain a bit sort of vigilance around that. Next one down is our flatworms, our planaria. These are unsegmented worms. They have a range of cilia, which are tiny little hairs, and they use the cilia to kind of move along. They can move along quite quickly in a kind of relative sense, and they can form chains, so they can actually work together collectively to form a chain. And I always quite liken a lot of them to little kittens. They tend to have little ears, and they're quite cute. And you normally find them at the bottom of your sampling tray, sort of tooling along, just pottering about, hoovering up debris. Flatworms are quite fun, though there are invasive examples of those. So the New Zealand flatworm, which has got a large one, has been tracked from the north of the country, from Scotland, slowly making its way over the last couple of decades south. Not sure what it's heading for. Maybe it's going for the London Eye, still thinks it's open. But it's on its way south, so not all good news. We have quite a number of species of leeches. They tend to produce a great sense of sort of revulsion in people, but they are an important part of the kind of life cycle, the chain. They are a detrivore, so they'll work on carrion, dying fish and amphibians, and they will also attach themselves to living creatures and suck blood, quite literally, which is why they've been used in the past, and they still are now, in the treatment of bleeding within major operations, particularly used to keep blood flow going while a procedure is taking place. So there's our particular species of leech that are used in medicine now. But they're not attached to the head from a cup of 12, as in Blackadder, I think was my last mention. Now, unfortunately, like a lot of other species, they're they're subject to habitat loss, to drainage, and some of the more unusual species, we need to respect all wildlife, even the ones that make us feel a bit creepy, are in decline. One of the things I noticed, we had a sample of leeches, we had a spoon, and we put the leech on the top, and we could see the leech was reaching for something, and as we moved our finger around the spoon, the leech actually followed the finger. Now clearly it's detecting heat or CO2 or the chemicals that are on our skin or the oils. So they're quite sophisticated creatures. They can work out by that smell, taste, chemical, sensory function where things are that they might be of interest to them. So we quickly put that one back. A lot of creatures spend just part of their life cycle in water. So here's an example of the main kind of groups of the Mayfly. These are the Mayfly nymphs. So we have swimming nymphs. They tend to be sort of torpedo shaped. That's the top right. We have Mayfly larvae that will burrow down into sands and gravels. And then we have our sort of flattened larvae that actually cling onto rocks, the clingers. They're adapted to a different niche within each of their gross environments, let's take a small mountain brook. So the better day, those swimming Mayfly larvae are very good at energetically maintaining their position in the water course. The flattened larvae, the Mayfly, the clingers will hang on in extreme flows, but maybe that's because they need that higher flow rate for greater oxygen demand. And then the burrowing have chosen to hide from predators by covering themselves with gravels or sand or loose sediment. But all of them have external gills, and by using a hand lens you can just hover over a larva and you can see those gills just pulsating and absorbing oxygen from the water. And when I first noticed this, it's just phenomenal because they pulse in the most amazing way, and sometimes they're in time and sometimes they get a little bit disruptive and sort of fibrillate in a different way, and then they recover and then they're back in time again. So absolutely gorgeous to see that level of sort of biological adaptation to their environment. So Mayfly have 2 cycles in terms of their flying forms. So the dun is their flying nymph, extremely vulnerable to predation at that point, and later on they will molt again to become what a lot of people would call the spinner. And a few years ago we had Ephemeroptera, the ephemera, this sort of Mayfly, quite a large one, and we'd managed to time a paddle on the River Severn in a Canadian canoe, and we were right in the middle of the hatch. And the water was just covered in molted and shed skins, and then the air was just full of Mayfly, these ephemera, probably very similar to the one in the picture there. And fish like trout will rise and just grab those opportunistic meals floating around on the surface quite easily and quickly. Apologies. Water quality kind of dictates and influences the range of invertebrates that can tolerate the conditions that are present. So you may have low oxygen levels, there might be high nutrient levels, there might be high temperatures, you may have low temperatures, etc. So you start to multiply these variables, and certainly the stoneflies are quite intolerant of dirty water. The greater range of species tends to be found in the kind of Midlands going north, because the water tends to be quicker, faster and cleaner. The southern rivers down in Sussex, Kent or East Anglia tend to be slower, they're warmer, oxygen levels are depressed, particularly the chalk streams of the southeast. A lot of over abstraction means water levels are very low, so they heat up really quickly and the oxygen gets stripped out of them. So stoneflies, again, like it clean, like the river to run quickly, and unlike the mayflies, which have 3 tails, the stoneflies have 2. So identification to split those 2 groups into their respective kind of piles is relatively easy. After that, a bit tougher. And I always find I kind of get as far as the 2 tails, 3 tails and go, oh, that'll do me. I've got a stonefly or a mayfly. But it's the start of a journey. I can see a door opening that possibly I'm not going to go through, but somebody else is. There's a telephone there. Damselflies have 4 wings. They're roughly of the same length. They fold those wings up back and above their body. Not quite a tent, but pretty close. When they are first hatched from the nymph form, they tend to be very pale, and then slowly the colour develops over time. When the nymphs are in the water, as you can see from the nymph picture on the bottom right there, they have at least 2 lamella, which are tails, and the lamella are striped, or they're one colour, and each lamella is striped in a particular way, and each species has got its own coding. And what's really super about the damselflies is you might catch one of the nymphs in a net if you're doing a bit of sweeping in your local brook, and it's relatively easy, with a bit of time and practice, is to use the lamella to identify which species you've caught and then to return it. What I don't advise is obviously catching the adults. They tend to be very fragile. A lot of damselfly enthusiasts will use binoculars or very quick photographs, quickly taken photographs to identify them. And then the other way to do that is to look at the tail or the body. And most damselflies, and it's just a representative example of the blues, have got a whole range of shapes and combination of stripes. And by quietly parking yourself by the riverbank or in a boat and tying up and sitting still for a while, a lot of times they'll land on vegetation. They'll pause for quite a long time. In mating, they connect in that classic S shape and whiz around. But with patience, you can start to pick up the different shapes on the body, and these indicate which particular blue or red, or whether it's a darter damselfly you're looking at. Again, I think that we're just kind of opening the door. I know that there's blue ones, there's white-legged damselflies, but a lot of the blues I hesitate about. But given a bit of time, I can slowly get a bit of identification, and certainly carry a really nice book, the Collins Field Guide to Freshwater Life, which I find has taken me as far as I want to go. And they've got some good ID support in there to get that comfortable recognition. Bit bigger, louder. I've had some lovely encounters with brown hawkers this year, which are our largest and our only brown dragonfly. A few emperors too, but the brown settled for me, and I'd had enough time to take a clumsy, badly focused picture of it. And you can hear their wings, they tend to clatter. They have a rustly, brittle sound to them as they whiz about. They're very aggressive. They do quite literally hunt their prey. The skimmers will park up for a brief moment, just checking their territory out before zigzagging or quartering the pond or the canal or the river course that they've decided to adopt as their hunting home. The lymphs don't have tails like the lamellae, like the damselflies, and they have a set of short spines instead. And when they emerge, they'll crawl out of the water, up a piece of vegetation, and they'll leave behind what they call an exuviae, their kind of case. And that case has got sufficient information on it for you to identify what the adult was. And certainly a lot of the, let's say, clubtail dragonfly research is based purely on finding the cases. And here's a lovely 7 specialist. This is the club-tailed dragonfly, Gonphus vulgatissimus, on one of our canoes during one of the survey trips over the last couple of years. It does have quite literally a club tail, but it's also this fantastic deep matte black with these yellow stripes on it, and the exuviae are very distinctive and normally found on mud banks, whereas I think the kind of emperor Cyanea, they tend to leave their exuviae on emergent vegetation. Different shape, different arrangement of spikes, slightly different size, and again certainly at certain times of the year, back in the let's say late May, June time, is a good time to go looking for exuviae cases and starting to record where those are. And a case constitute a biological record. There's nothing else has left it behind. You may not have seen the adult, but have found in the case, and that's a good thing to record. And the British Dragonfly Society in the UK regularly produce an atlas of dragonfly distribution. And in Shropshire we have a sufficient range of water bodies of one sort or another to support a considerable number, including sort of the white-faced darter, of dragonflies and damselflies. I do think, again, it's something that if you want to specialise in something, they are absolutely gorgeous. Still flying now, even though we're nearly at the end of September, but I certainly saw an emperor, southern hawker, over the weekend within county. So on to our water bugs, Hemiptera. So again, as I say, these are just aquatic versions of the bugs that are normally found on leaves. They are either carnivorous or omnivorous or herbivorous. They tend to have a rostrum, which is a mouthpiece underneath the head that they flip out and either pierce their prey. Water boatmen, for instance, are quite aggressive, will bite your finger. So it feels like a bite, it's more of a piercing action. And water boatmen will swim upside down, and the other ones swim the right way up. And I can never remember which one round it is. So the bug's great, really nice family. Water measurers tend to be slow and deliberate. Water crickets, really tiny and very, very quick, but they all use the surface tension in some way or the other. Water scorpions, completely different thing. They move very slowly, quite tolerant of low oxygen conditions, and then they're quite large and quite scary, but not really. They're far too slow to be really genuinely scary. So water bugs are fun. Not too large a group, but certainly a group that's found quite commonly. And I particularly like the pond skater, my favourite in the centre there. You find a little troop of pond skaters will actually maintain their position. They quite like a patch. It's obviously delivering enough food for them. And despite the flow of the river, they're quite economically managed to stay in that patch just by pushing around beautifully on the surface. Caddisfly, huge family, absolutely massive, very difficult to identify down to species, but they do help us out a little bit because each species constructs either a refuge, a net, or they're free swimming, and they just take refuge in gravel. And each species has a different sort of refuge, so it'll use stones or sticks or leaves. Some have got little doors on them, some have got no doors, some have got a hole in the end of the refuge and some haven't. Some are curved, some are just beautifully smooth, some are really messy, and the list goes on. So caddisflies are great, and the adults slightly more tricky to identify, but they're beautiful. They tend to be soft and a bit sort of misty or smoky, but on their legs they have tiny little hooks on the joins, and they're rather like steam trains, is they'll either have 2 hooks, 3 hooks, no hooks, so you've got 2, 3, 0, or some other combination on their legs. And they tend to come to moth traps, so that's quite a fun way of collecting them and starting to identify them. Caddisflies, great fun, really nice group to kind of get your head around, and you'll get different caddisflies will occupy different places. because of the habitat, water quality, or the kind of nest building or refuge building material. And one of the family that you don't to find the nets, they make and weave a refuge net that they kind of creep back into, but these tend to get blown away when you're doing any sampling. Huge group here, and I kind of get started and then I realise it's slightly overwhelming, but nearly all of these, the midges, the mosquitoes, crane flies and the horseflies, will have aquatic larvae. So part of their cycle is dependent on laying their eggs into water or into damp conditions, and then you end up with the adult. So a very big, large group to grapple with. And certainly the mosquito larvae are really quite obvious. They kind of flick around in that question mark way in a barrel or a bucket. Okay, so we have the beetles. Again, I think it's a large group. It's quite nice to get started on, but there's probably about, I think it's about 400 aquatic beetles, and here we just got a few. Most of the larvae tend to be quite aggressive. Certainly the diving beetles are carnivorous, and other beetles occupy that position. So their larvae are very different from the adult form, and that's subject, I think, again, they're beautiful, they're gorgeously shaped and coloured, and it's something to dive into. Spiders. There is only one genuinely aquatic spider in the UK. There are lots of spiders that will use the surface tension to move around, but there's only one truly aquatic species. I think that's kind of a bit of a help there, really. But you will find other spiders that have dropped off of bushes or trees that kind of confuse the picture a little bit. And certainly our raft spider, we have the Great Fen raft spider up in the north of the county on the meres and mosses. So it's one of the larger versions. But the spider's quite a nice, easy one if you're going to get into rivers and aquatic environments. Another little intro thing. When I was a child, I used to study, and not study in a kind of formal sense, just stare at the little red mites that crawled all over the walls at the front of our house where my camp was. And in the water there are mites as well, and they tend to be parasitic. I didn't know that when I was a kid. I just loved them, these tiny little things moving about. And there's a whole range of parasites or ectoparasites that coexist with fish and larger creatures in the most interesting of ways, if you can get over the fact that they're parasites. So I'm nearly coming to the end of the Seaman's kind of trawl, and as I say, I concentrated on the small stuff, a little bit of an overview on the plants, and my last few slides, this one particularly is about the fish lice, and fish lice tend to occur on fish that are either in overstock conditions or they're in poor health. And the fish lice, this particular one is Argulus in the photograph there, will start to predate on these fish. And the most recent time, again, I found was a batch of, dace and roach that I was looking at. I fish, obviously I'm an angler, as much as I do all the other stuff, and I could see that these fish were in poor condition and they were covered in lice. So partly that's maybe overpopulation, poor water quality, and I say this is quite an indicative issue, and it's one of those fundamental conditions and problems with fish farming. Last group, what we've got now is the crustaceans. Huge, great family. A lot of the ID work requires a microscope. And I suppose the one that's most commonly found in water is the water hoglouse. It's kind of the aquatic version of the pill bug. Multiple legs, tends to crawl around in leaf litter and debris at the bottom of a stream or brook. And finally, slightly larger are our crayfish, of which there's a number of alien species in the UK. But fortunately, I think we can say that it's still in Shropshire we have the white-clawed crayfish. And we do have colleagues who could possibly give us a much more detailed presentation sometime in the future. And in that sort of wear your shell on the outside, we have our limpets, large group, and I think I might come back to those in the future and spend a bit more time explaining those. I'm conscious we've taken up quite a lot of your time this evening. So these are the ramshorns, clams, zebra mussels, and we're coming to an end. So Shropshire Rivers Hub is the part of the Shropshire Wildlife Trust website that looks at the aquatic world, at freshwater stuff. We appreciate those of you that support us as members. It helps us do the work that we do to protect wildlife in Shropshire. And if you can support us again in the future, we'd appreciate that very, very much indeed. Follow us on Twitter if you wish. It's LYR Shropshire. And tonight was the last of our weekly talks. We're going to gently swap over to a sort of a winter regime of monthly talks. And we really would like to hear from you if you got a topic that you think you'd like to hear a bit more about, particularly in Shropshire. Shropshire is an enormously diverse place, lots of different habitats, lots of different species because we're kind of in the middle here. Then please let us know. We'd love your feedback and your comments. Again, and thank you very much for tuning in this evening. Take care and don't forget to explore a bit. Get your wellies on. Take care now. Bye-bye.